Hi everyone, I'm back and we are going to explore further in vectors. So this time around, today's lesson, we are going to focus on addition and subtraction of vectors. Okay, so first of all, let's focus on addition of vectors. We are going to stop having simple vectors like from just traveling from A to B. So right now we are going to explore even further. What about we having 3 or even 4 more points? So first of all, you take a look at this. As usual, we start with something simple from A to B. So the vector representing this will be AB with an arrowhead on top. Now, as like what I've said just now, we are going to include another arrow in this case. So the green arrow will represent a movement from B to C, and the vector as illustrated on the slide as well. Okay, now so if we are not just talking about moving from A to B, but if our final destination is from A to C, how are we going to do that? Take a look at this triangle. So beside traveling straight away from A to C, the other route will be traveling from A to B first and then from B to C. So look at the blue color box up equation. You will see that AC is also at the same time equals to AB plus BC. Okay, so sometimes when you have two vectors that add together, if the last alphabet of the first vector and the first alphabet of the second vector, if they coincide, actually the final result will be just taking the first letter of the first vector and the last letter of the second vector, as indicated by the red arrow. So remember matrix, whereby how you check for whether the matrix is multiplicable. So when you multiply two matrix, you check the rows and the column. So exactly this is about the same skills when you are using addition of vectors. Okay, so let's try another example. So look at the slide, whereby your job is to find what is the resultant of the following vectors. If I'm traveling from A, C, and then CB, and then finally BD. Okay, so if we are going to represent this in a graphical form, you will see that these are the arrows that's representing movement from A to C, C to B, and B to D. So following this route, the final result will be, of course, from A traveling to D. So the final answer, you can see that it's just AD. Okay, so once again, if you look at how are we going to obtain AD straight away by not drawing the diagrams, let's focus on the blue box over there. As what I've said, you can actually just cancel off the last alphabet and the first alphabet of the first and second vectors respectively. And if we do so for the next two vectors, you will see that the B and B can be cancelled off as well. So eventually what you are left with is only A and D. Okay, so it coincides with the answer which we obtain from the diagram. Okay, so with this, I think you have a rough understanding of what is addition of vectors. So we are going to move on to subtraction of vectors. So you have to take a look at this parallelogram. We have ABCD as the parallelogram. let's say when we travel from A to B is denoted by a vector called A, and if we travel from A to D is denoted by the vector called B. So if you are interested in finding how are we going to represent the movement from B to D, the vector BD, we can actually do the following. So from BD, actually we are traveling from BA to AD. Okay, BA to AD. Okay, but we only know that from AB is positive A. So by traveling in a different direction, B to A, we are going to change the A to a negative A. And from A to D there's no changes because it's the same direction, so we just copy down B. So this would be the answer. And I guess some of you might have the question, if I want to travel from B to D, I have another option. Okay, we can actually travel from B to C and C to D. So if you notice, since this is a parallelogram, BC would be the same as AD. So eventually you should get the same answer. Okay, let's look at the next example. We have this equation, also called vectors, PQ minus PS. Okay, for this example there's no diagram, so it's a bit abstract, sorry. And what you need to do is, of course, do some trick to this so that you can get the answer. So let's take a look at the solution. So we know PQ minus PS, we can definitely change the PS, okay, negative PS to SP. Okay, because negative PS means it's traveling in a different direction. So we can also say that it's traveling with just interchange the position from PS to SP. And if we do a small trick whereby we shift the SP to the front, you will notice that, hey, this time around the P and the P can be cancelled off. Because one of them is the last position and the second one is at the first position. So since they are side by side, we can just cancel and the final result will be SQ. Okay, with this, I'm not stopping you to actually evaluate PQ minus PS using drawing method. But you should understand that drawing method takes time. But if you find that you are weak in this, maybe as a beginner you might want to use drawing to understand, and I'm not stopping you to do that. Okay, so I guess enough for me talking, and you should start doing the questions from the exercise book. Questions from the textbook. So everyone please turn to page 99 of the textbook, focusing on the exercise 3B. Let's try question 5, 10, and 14. Do all these questions on a piece of foolscap paper and submit this at the end of the lesson to the relief teacher. Okay, he or she will just put the exercise attempted questions on my table. I hope that throughout the video you managed to copy certain important details in your exercise book. If you haven't done so, please go back home, re-look at the video. Since it's on YouTube, you can watch it 24/7. And if you still have any questions, you can post it on Facebook, you can post it on YouTube, and I will try to answer the questions. And with this, enjoy doing your homework, and see you in next lesson. Bye bye.